Hello, I'm Stefan Greber, I'm the project leader for LXD, and this is the release livestream for LXD 424. We tagged that release on Thursday last week. It took a little while to get the announcement sorted due to some other things going on. We had the LexCFS 5.0 release also happening last week, which caused some regressions and needed some fixes. Anyway, the announcement itself for 424 was published yesterday evening. And that's what we're looking at right here. The first thing to mention is that LXD 424 is going to be the last release of the 4 point release. The next release after this is going to be 5.0 LTS. We don't really do anything very special for when we release the next LTS. We actually like the difference between the last release of, in this case, the 4-point branch going to 5.0 to be as small as possible. It's mostly an indication that at that point that new release 5.0 will be supported for 5 years and get regular, pretty frequent bug fix updates and security updates. But we still have a few things that we do need to sort out, so there's going to be new features in the 5.0 release. So, looking at 424, what's new in there? Well, the first thing is a completely new files API. We looked at a few different options. Basically, the reason for that was our files API, while it worked fine, was slow and not very featureful. So you could get files, put files, delete, get some information about directories and that kind of stuff. But you couldn't really get detailed ownership, permissions, or similar attributes, or do symlinks, hard links, any of those kind of things. And every single file operation would effectively cause a sub-process to be spawned, attached to the instance. The action you wanted would be done inside it. And then the process would exit effectively. This is okay if all you're doing is like pulling a few log files or pushing a few files here and there. But if you're doing recursive push, that could potentially interact with hundreds of thousands of files. Or if you're using a tool like Ansible, which was getting files constantly, comparing them, looking at whether they change, whether there's anything to apply, and then pushing files back. That was getting very, very expensive. You could easily get hundreds to thousands of processes spawned every second to just deal with files operations, and it was really causing a lot of load. So we did a few things. The first thing we did was completely replace the way we were handling files internally, so that instead of spawning one process per file operation, we would spawn one process that would linger for up to 10 seconds and could handle multiple requests. The way we've then done the communication between LXD and that process itself was to use a native implementation of the SFTP protocol. So Go has a native implementation of it, which worked pretty nicely. That meant that LXD would then talk with that small server in the container over an API that could do parallel file transfers, could do a whole lot of different file operations, like far more than we could ever do before. And for virtual machines, it also let us implement the exact same endpoint on the LXD VM agent and get the exact same behavior there. So that was pretty good. Doing that actually meant that we improved the performance of the normal files API significantly with that. You could run transferring, I think my worst case scenario was something like 20,000 files for about 200 megs. That was literally taking close to 15 minutes in some cases and went down to a few seconds. Part of that is because we don't need to do all of the forking and all of that stuff, and it was still over the old file API. But also part of that is because the new logic means that LXD never needs to actually copy the data. We're doing streaming straight from the instance. There's no copy and no file usage in temp. None of that's going on. So there's no more memory usage, no more disk usage during file operations, other than the file itself being written inside the instance. So it's a massive difference. And then we took that one step further and we actually exposed that SFTP endpoint directly through the LXD API. Which then makes allowed to do something pretty interesting, which is effectively to mount an entire container or container directory. So we can see here, using LXD file mount to mount an instance on a remote server to a local file. a local directory. Once you do that, it just tells you SSHFS mounting this thing. You do Control-C if you want to disconnect, and in another shell, you can then access it and list it. That's done by effectively getting that SFTP protocol over the LXD secure API to the client. The client then feeds that into the SSHFS process using effectively a pipe, and then SSHFS mounts it using Fuse on the client. And that works on Linux and macOS clients. If you're using Windows, which doesn't support Fuse, you instead get presented with a local host SSH server that implements, again, just the SFTP API, and you can then use an external tool like WinSCP or I guess FileZilla or something like that to connect to that SSHFS SFTP endpoint on a local SSH server. So that's hopefully going to be opening quite a lot more opportunities for a bunch of people, and it's quite an exciting feature. Sorry. Next one is the cluster event hub role. That one we've been trying to do for a little while. We finally got everything kind of lined up with this release. Basically, when you're dealing with a very large cluster, and the example here is not a large cluster, just 7 machines. But if you're dealing with clusters of 20, 30, 40, 50 machines, the default event handling in LXD, which is a full mesh where every single server sends their events to every single other server, that gets a bit difficult to really reason about, to keep track of. So instead, what we have now is a role that can be assigned to a couple of servers, or at least a couple of servers. And then all of the other servers will send all their events to those two, and will receive all the events from one of those two hubs. The benefit there being that all of the traffic and duplication and everything is just handled by a few select machines, and you can kind of choose which one you want. So you can look at which ones are your current active database nodes, and put the event hub role on others to try and better spread your load. The next feature has been a bit of a rework of the LXD storage volume info. In the past, that command would just show very basic information as YAML, which was then missing a few things. It wasn't really show details about the volume itself, like its content type, its list of snapshots or backups, or any of that stuff. So we've reworked it, made it look very similar to the LXD info output instead. And that's what we can see here. It now shows, in this case, snapshots, but if you've got backups, it will show those too. The next one is a bit of a security improvement, so not very visible to the user, but something we've been meaning to do for quite a few years, where basically LXD needs to unpack images. We normally consider images to be mostly untrusted as far as LXD is concerned, so that's why we don't let images include configuration or any of that kind of stuff. LXD downloads the image from a remote image server, but then it needs to unpack it, and that's the really risky part, which we didn't have too much protection for in the past. Whereas now we do. So effectively what LXD does now is every time it needs to unpack an image, whether it's a Squashfest, a tarball, or anything else really, it will generate on the fly an AppArmor profile, which then restricts exactly what commands can be run, what files can be read, what files can be written. And then the unpacker runs under that profile. That means that even if someone finds the bug inside the Squashfest format or inside the tar format or in one of the compressors and decompressors for tar, they won't be able to actually go and read files from your system or modify files from your system outside of the directory that it's supposed to be unpacking the container into. So that makes things quite a bit safer, something we've been meaning to do for a long time, so it was great to see it done in this release. The next one you might have seen already on the forum or on Twitter, or a bunch of other places, but we've got an official Grafana dashboard now. It's published on the Grafana website directly, and it effectively gets you an overview of your different projects and the resource consumption inside them, as well as all of the individual instances. You can kind of expand and go look at what's going on. The idea is to really show, what's the resource consumption of a given project like, and potentially also identify issues like, a project suddenly using a lot more memory or CPU than it used to, and easily finding those issues. The other one is something else that's been requested for a while, quite exciting to see it done, is the degraded startup. In this case, missing disk. We're still working on missing network. So it means that now LXD can have storage pools that cannot be mounted, and LXD will still start up. The storage pool will be marked as unavailable and will be retried in the background. And once it gets successfully mounted, instances that depend on that storage pool will then be started. That's quite different from what we used to have in the past, where in the past LXD would track all the storage pools on startup. If any of them couldn't be mounted, it would just fail right there. There is one restriction here, which is that there are still cases where LXD does need all the storage pools present at startup, and that's when it's handling an upgrade. In such cases, if you are missing a storage pool, it will still fail startup. But for the most common cases, now it will cope just fine. The storage pool will show as unavailable, and you can fix it up later, effectively. That makes it possible in some cases to now use a storage pool on external media, for example, like a USB disk or something like that, and let your machine start without it, and then later on plug it in and have it be detected and have the instances come back online. Then we have a couple of configuration keys here. The first one is a config key on projects to allow for restricted projects to use system call interception. So one of the reasons why you might want to do that is if you want to have restricted projects that would still be allowed to run, say, Docker containers. Docker will often need at least two of the syscall interception options to be enabled, specifically the make node and the set extractor ones. Right now you couldn't do that. With this option now you can turn it on and the user will be able to do this. It is still restricted, so the user will not be allowed to use those two config options listed there, mount allowed and mount shift, because those two are very easy ways to effectively take over the entire system, which is not very good. So those are blocked. Everything else is currently allowed, and there is a mention in the announcement that it does increase the attack surface significantly, because syscall interception effectively has a system call in an unprivileged container intercepted and rerun with elevated privileges if it matches some non-good patterns, effectively. But if this is abused, then it would in theory let you cause a more privileged process to do something on the container, which is not very good. The other thing is that it can lead to denial of service attacks, because it is quite expensive to process such an intercepted syscall. So a malicious container could significantly slow down the system just by flooding it with intercepted system calls, effectively. So something to keep in mind. It is an option for restricted projects. Only really enable that on projects where you trust the user owning the project, not to abuse that, and then have that user only enable the intercept options on containers that they effectively trust to use that feature. The next one would be the container metrics authentication option. So we did have requests from some folks about being able to access the new metrics API without needing a valid TLS client certificate. So that's what that option does. If it's set to false, then you'll be able to connect to the metrics endpoint. It's still TLS, but it is not going to be doing client authentication on it. So anyone who connects to it can see every single metric. The next one is another thing that was requested a few times. Effectively, inside virtual machines, you might have noticed that the name of the network interface in LXD does not line up with the name inside of the VM. The VM usually gets something like ENP5S0. It also gets whatever MTU is advertised from the DHCP server, effectively, or will default to 1500, and does not necessarily line up with what's in LXD. That's simply because, unlike with containers, we're not creating that device. It is just there, like it's in the machine definition in QEMU. And even QEMU doesn't control the name of the interface. That's usually left to something like udev or systemd inside of the VM. But since we're running LXD agent, we can actually rename things. So that's what that new config option called agent.nickconfig lets you do. It makes it possible to, what it indicates to the agent that we want the network interfaces renamed and reconfigured to match what's in LXD. The one caveat there is pretty much all of our images assume that the default network interface is called ENP5S0. So if you rename your interface to something else, it's probably not going to get an IP, and I'm going to need to reconfigure the network interface inside of the VM to line up. The next thing is also VM related, which is the IO uring support for VM storage. So IO uring is the effectively new-ish kernel API for IO, which is quite interesting because it doesn't rely on system calls. As a result of that, it can be extremely fast. It's really been beating like all kind of storage performance metrics lately, and yeah, it can be really impressive when it all works properly. So starting with this LXD release, we're trying to do as good a job as we can to detect whether it's going to be working or not on a given system. So we know kind of what storage backends, storage pool drivers might support it. We can check whether QEMU itself supports it, and if everything looks good, then we're changing the QEMU backend for those specific disks to using IO uring instead of normal async IO backend and direct IO backend. So this hopefully means LXD VM just getting faster for people that have a compatible systems there, and hopefully no regression for anyone. And the last thing on the list is a new config option to control, so that's specifically for rooted NICs, to control whether to do duplicate IP detection effectively. So that's a feature that was added in 4.23, I believe, where on startup of a rooted NIC, LXD will try to see if the IP address, IPv4 and IPv6 addresses already exist on the network, and if they do, it will fail the startup, saying that like, hey, that's already responding. You should go and figure out what's going on there. But there are some cases where you actually do want it to still start, and so we've added now 2 config options to let you disable the neighborhood probe. So that's the IPv4 neighbor probe and IPv6 neighbor probe config options. And that's it for the new features. So let's back up and then switch over to a terminal to do a bit of a demo of all that stuff. All right. Cool. So first thing first, the first one is the file mount and new files API. That one is a bit annoying because we're still struggling to find a way to make it work nicely with the snap. The snap package by design is confined, and part of the confinement is it runs inside of its own mount namespace. So it's unfortunately not as easy for us as just dumping a SHFS in the snap and calling it done, because even though it would work as far as calling a SHFS, it wouldn't mount it anywhere visible from the host system, which is making it not terribly useful. So we're still working on that. There is the option to use the --listen option, which spawns an SSH server instead, and you can then use SHFS against that. But in this example, I'm just going to be using a non-snap version of the client to just show how things should be working, and hopefully we'll get to that point in the very near future with the snap. So I'm just going to be adding my local binaries in the path. So if I look at LXC now, I should be using that one instead of the snap. Yep. All right, let's switch to remote server. Right, so I've got 2 instances running here on a remote cluster, U1 and U2. So I can just make the U1 file mount U1 into U1, and that failed. Oh right, that's a bug I fixed. Yeah, today, actually. That's going to be fixed by the time 424 hits users. It's just an issue with handling projects on the remote server. Okay, so I just need to use a local one instead. Let me just fix that. Okay, so let's try it again. This time I should be dealing with my local instances. If I switch to the local remote, those will work fine. All right. So let's see, file mount. Let's pick, I guess, the virtual machine v1. Oh, let's have Grafana, which is a container. So I'm just gonna create a directory called Grafana and then do file mount Grafana into Grafana. Okay, so it shows HFS mounted on Grafana. If I get a second terminal here, you can see the file listing, and you can go and like just go look around the instance, like the Grafana directory here. The user and group ownership obviously can be a little bit all over the place because the UIDs and GIDs inside of the instance might not line up with your host system, as can be seen here. But still all works out pretty nicely. And once you're done, you just Control-C the top one, and Grafana is now turning back into normal directory. You can delete it. And just to show, it works the exact same with a VM. So if I do v1, and you can also pass a specific path. So say I just want ITC from that VM. I can do that. And now I see the content of /ITC, but appearing inside of that fuse mount here locally. So that's how that stuff works. Now, as I said, if you're using the snap, or if you're using this on Windows, SSHFS can't be directly called by the snap package. So instead, you need to use the listen option. You can do something like this. I believe you're right. Nope, target path. Then that makes sense. All right. Okay, so just need. Come on. There we go. So that's mounting again instance v1, and this time it shows up on a local SSH server effectively. That's running directly from the LXD command line. Let's see if I can remember how to do that with SSHFS. I think I need to do dash. What's the port option again? Because SSHFS is a bit picky about the ordering of its arguments. Okay, mount port and options go last. Okay, so the port is 33143, and let's just do root at 127.0.0.1 and mount that on v1. Yes, so we can see the top now it shows SSH client connected, and again v1 is now mounted. Once you're done, you need to actually terminate this, which is a bit harder because SSHFS doesn't linger. So fuse mount in this case should do it. You can unmount this, and then you can Control-C up there. So that's the alternative. We're working on changing that workflow a tiny bit to also use a username and password, just so that right now anyone who's on your local system can effectively use SSHFS, which is not ideal. So we're going to be adding a bit more security there. But that's the fallback option when having SSHFS directly integrated with LXD file mount doesn't work. All right, well, that was a pretty long one for the first item on the list. Let's go to the next one. So the next one is the event hub. So if I switch my remote again here to my local cluster. Making sure this works. It does. Let me adjust the zoom level. There we go. So that's my home cluster. I've got 7 machines, and right now we can see that all of them, well, a bunch of them have the database roles. One of them is the leader. 3 of them are voters, so that's those, and 2 of them are database standbys. So that all works out. It's fine. In that cluster, if we go look at info, we can look at server event mode, and this will show full mesh. So right now, they're all interconnected, and all events just get sent to all the others from every single server. we can change that by doing edit on, let's do apps. So you go to the roles section and add event hub. And at this point, it should show up in the list as an event hub. But if we look at this, it still shows full mesh. The reason is that we need redundancy. We can't just have one event hub, because if that one goes down, then everything goes down. You need to have two. So that's why you need to go edit the second one now. And go event hub on this one, for example. So go look at the list again. Now we've got two of them with event hub added. And the mode is now hub client, which shows that the particular server I'm talking to in my cluster is a client of one of the two event hubs. And that's effectively it. Like that's very seamless. If event hubs go away, LXD will fall back to full mesh mode. So there's no real downside. And effectively, if you see that your performance kind of misbalanced, that a bunch of your servers are using far more CPU than they possibly should, that's one thing you can now do to rebalance things. And if you want to turn it off, you just need to go and edit the machines, remove the role, and you're back to normal. All right. The next thing is the reworked storage volume info. So if I go back to my local LXD, do storage list on the default pool here. Let's just make local, volume list, sorry. Okay. So we can see that I've got a volume here called foo, which has a snapshot. So if we go look at the info for that, volume info, default pool, volume is called foo. That's the new output. So we can see that there is a custom volume, that it's of, it stores a file system, not a block, and can see the snapshot it has and how much space it's using. So that's effectively the new output. If there's a backup will show up underneath as well. And that's pretty much all that there is to it. It's just easier than before, because in the past we didn't have the backups or the snapshots listed. You needed to use list and use info to kind of get everything you needed. Now it's all there. The next feature is the AppArmor profiles for image extractors. That one I can't really demo because it's just there. Like every time you unpack an image, it just happens. So if I do, like just doing that, it will have done it. But yeah, there's nothing really user visible other than it's there, and it's an extra security layer. The next thing is the Grafana dashboard. So that one I can show, and I did already in another video, so probably won't spend too much time on that. But that's effectively what it looks like. So this is for my other cluster, where we can go and look at different projects up here. Select as a demo project. If I take one of the busier projects like core, it will show me the top 5 for CPU usage. So I can see that the 3HE proxies that serve, most of the things, the image servers, are the busiest. Then it's my VPN server, and then Prometheus. Same thing for memory. You can kind of see where the memory usage is going. Root file system, same deal. And you can see for the total project over that period of 6 hours, the network transfer that happened, as well as the reads and writes to the storage. It shows a nice overview of CPU, memory, running processes, disk usage, bandwidth usage, both to storage and to network. And it also shows, you can get a graph of occasional network errors and that kind of stuff, which could be quite useful or packet drops to see potential network issues this way. Then if you know that you're going to be looking at a specific instance, you can just pick it in the list, expand it, and then you get the slightly more details, like similar graphs, but slightly more details for that specific instance, which makes it really easy to go and troubleshoot issues. Again, I'm not going to go into too much depth here. There's a full video on how to set up Prometheus, Grafana, and getting that dashboard and everything imported or everything set up. So if you're interested, you should go and look at that instead. All right. Next up. So next one is a degraded startup missing disk. So I've got a local VM called v1, which I can go into. And that VM actually has 2 storage pools. And we can see one of them is marked as unavailable. So that's the new thing. In the past, unavailable was not a valid status for storage pool, and you could never get in that state. That particular state would normally be LXD not starting up. So in this case, LXD did start up, detected that the pool is not available, but just marked it as such. And if I look at my instances, that A1 instance refuses to start because storage pool is unavailable on the server. Now I can make it available. Just in this case, it's a loop pool, so I'm kind of simulating a disk being plugged in. LXD will eventually notice that, but it retries, I believe, every minute, so it's gonna matter of luck as far as when is the next time it's gonna be looking at that. So I'll just move on and then come back to that in a little bit, and we should see that it detected the pool as being available and that the container can then be started properly. All right, so next, we've got the restricted project feature. Oh, actually, got lucky. There we go. Just shows initialized storage pool, mount started, mount finished, all storage pools initialized. So now it's created, and if we look at the instances, if it had been running before, it would be auto-started. In this case, it wasn't, but now I can start it just fine. So that's that feature. Alrighty. So next feature is the restricted option for system call interception. So if I switch to my demo project, don't remember if demo is currently restricted. It is not. Okay. So let me make that restricted. Okay. And let's launch a random instance. Okay. So out of the box, if I wanted to do security, syscalls, intercept, so specifically the combination needed for Docker would be set xada and security syscalls intercept make node. So those two would be what's needed, but it says interception is forbidden. Now, if we do the project and we go and do restricted.containers.interception, now it works. But that's really all that there is to it. It makes it possible to set those particular options. As I said, it does not allow some other specific ones. So this one is still not allowed. So that's for this particular feature. The next one is the metrics authentication option. So let's see, I don't remember if I've got a metrics API endpoint set on this machine. I do, 1, 2, 3, 4, okay. So metrics. Right, so it currently says not authorized if I try to hit that particular endpoint. It would be different for us to use the right client certificate. But now let's do core metrics authentication false. Now it's taking a while and I get all my metrics back. So that's that particular option. It defaults to true, but can be set to false to then allow access by interested users effectively to that API. All right. Next up, next would be the network interface NMTU in virtual machine. All right, I think I only have that one. Well, switch back to my main project. Yeah. I think I can use that v1 VM I was playing with for that. So let's stop that. So we can say currently it was using ENP580, which is kind of a normal way for virtual machines. What we'll do now is just flip the new config option, which is agent.nickconfig true, and start it back up. And that will effectively instruct the agent inside of the VM to line things up with the LXD config, which in this case means that instead of ENP50, it's going to get renamed to ETH0. That will break networking because the config inside of the VM is to use ENP50, but just to show that this works. So if I start it up and give it a few seconds to boot up. It's not running yet. Okay, now it's running. We can see it's now called ETH0, and we can see the original name is stored here as an alt name. So if you were to use that, you need to then go and edit your netplan config in this case to replace ENP50 in there with ETH0, and then reboot the VM, and then it should come back up with an IP address this time around. So I'm gonna give it another few seconds to complete its reboot. Okay. And there we go. We've got connectivity again. EV4, EV6, it's all good on ETH0. And that's valid for both the name and the MTU property. So if you set an MTU in the LXD config, then it will work the same way and be applied by the agent on startup. Next one would be, are you uring for VMs? That's not something I can actually show other than just saying that this particular VM was backed by uring. I suppose we can go look at its actual config to just see that, but it's otherwise not very visible to the user. LXD logs v1 qmu conf. Right, so we can see that the block device for that VM came from ZFS, and the AIO mode is uring. So it is using the new backend, but yeah, it's invisible from inside of the guest and not particularly visible from outside either, other than performance just being better. And the last feature is one that I can't actually demo because I would need to get a full setup with rooted networking and potentially conflicting IP addresses to get it working. But that's the two new config options for IPv4 and IPv6 neighbor probe. Those are two config options you apply directly on the NIC. So if you are using a rooted NIC, it would kind of look like you would go down here. No, actually, this one doesn't have a device directly, but so normally you'd have your ETH0 in here. Type NIC type would be rooted. Name ETH0, parent ETH0, and that's where you would then slot in the new IPv4 neighbor probe and turn it off or on, but on is the default. And then just have it configured that way. This is not gonna work anyway, so I'm not even gonna bother saving it, but that's roughly what the config would look like. All right, so that is it for the LXD 4.24 release. Unlike in previous live streams, it's not available in the stable channel yet. I'm still doing a few tweaks here and there. As I said, we had some issues with like CFS, so I fixed the last issue of it this morning, I believe. We've got a number of cherry picks that are building now, and I want to see what I can do about the LXD file mount command before pushing it to everyone. I expect that 4.24 will still be slowly released over the next 48 hours or so. We always do a phased rollout, so it's going to be slightly delayed compared to usual, but at the end of the day, it still means that by Wednesday or so, everyone should be getting it. I hope this is going to be a good release for you all. If you have any questions, feel free to leave them either directly in the comment section for this video, or go on the community forum and maybe comment in the release post that you'll see here. And otherwise, well, I'll catch you in the next video. Have a good one. Bye.